Well, hello everyone. This is KP the Math G. Let me check my camera. I want to see. It doesn't look like it's pointing in the right direction. It probably needs to be a little more like that. Okay. It was. I just wanted to make sure it was all right. Hey, thank you for tuning in. I appreciate everyone. Please, at the end of the video, please, if you want to make a comment, hit the subscribe button. I don't know how many subscribers I have. I have an idea about how many, but if you don't subscribe, it's okay. If you just want to get something out of it and don't worry about subscribing, it's okay. If you don't want to make a comment, that's okay too. But it would be nice if you did subscribe, and it would be nice if you did make a comment. And if you comment saying, well done, great job, appreciate you, I appreciate that. But if you want to say, hey, you could have done this a little better, or you made an error here, please point out my error. Because I want to give you the best that I possibly can. If I'm going to be KP the Math G, which, by the way, I didn't come up with this name. I had students who called me first KP, and then as they found out I was doing videos, they said the Math G. So that's who I am. I'm KP the Math G. And if I'm going to be that, then I want to be at my best. Okay. We're dealing with the temperature of a pool of water. That is a differential function, W of time t. Differential just simply ensures us that there's no gaps or jumps in this data here that we have. There's no gaps. It's going to be a curve of some kind of whatever, decreasing, increasing. And in this case, it looks like it starts out a little bit increasing and then it decreases a little bit. Just notice those Y values right there. You can see that. Okay, the increments are in increments of 2, so we know that delta x is equal to 2. From previous videos, that's how you determine delta x. Okay, our interval is t is between 0 and 12, including 0 and 12. Okay, and we are approximating the average temperature. Okay, we're going to do it using the trapezoidal and midpoint approximations from this table. Remember now, when you do, we already did from the previous video a left approximation 22 2/3. The right approximation is 22 1/6. And if you average those two, if you add these two up and divide by 2, you're actually getting the trapezoidal, which, by the way, happens to be now 22 11/12. It's a very accurate approximation, and anyway, we're going to see if we get that, all right? And if we don't, well, I either messed up here or here, but I believe we'll see what we get. And alright, let's go ahead and get started. How do you do the trapezoidal approximation? Well, remember that, okay, when you're doing approximation and you're doing average anything, you're going to say 1 over and then 12 minus 0, which is 12. So 1 over 12, that's the average right there. You need that first. And then you're integrating from 0 to 12, W at t dt, approximately equal to. Always add that. If you're in the AP class, you need to make sure that you add this part right here. Alright, on with the show. Let's get started. By the way, if this is 0, this is F at 0. If this is 2, F at 2, and so forth. 4, F at 4, 6, F at 6, and so on. All the way to F at 12. Yes. Okay. Alright. Now let's go ahead and start. let's see, the rule is that you just take the first one, which is at F at 0 is 24. Now, oh yeah, it is 1/12 times delta x, which is 2, times what? Oh yes, we are dividing by 2 each time on your trapezoidal. You remember the rule is on the trapezoid. Okay, a trapezoid would look something like this. In this case, it probably would be pointing up for a little bit and then pointing down as this temperature drops. Okay, so anyway, it is height 1 plus height 2, and then times, or this is plus, these two are together plus, and then times delta x, which is 2, and then I think that's pretty much what we have to do here. Alright, I was thinking that there was something else that I may be missing out on. Oh yes, times a half, because we are, and let me just emphasize that again. Remember now, on a trapezoid, it is the area of a trapezoid is trying to think, height whatever, height 1 or whatever, plus, let's say I, plus height j, okay, and then you're multiplying by delta x, and then you're dividing by 2, kind of like a triangle in a way. Okay, so here's the 2 right here, alright, but then you are multiplying by 1/2 right here. So the 2 is the delta x, and the 1/2 is right here. This is 1/2 right here. Alright, and the 1/12 is the average. Alright, so you have to have all 3 of those in there. Alright, so there it is. Let's keep going with this one. Let me erase this because I have very limited room and I don't want to flip the board over if I can help it on this one. Okay, we'll worry about this in just a moment. Now, let's see. The very first one, it is F at 0, which is 24, plus 2 times 2 times 30. Everything is 2 times in between, and then the end, the 2 ends, you just have 50. Like on this one will be 24, the last one will be 15. But everything else for trapezoidal, everything else is 2 times in between. I don't want to go over the explanation of why it is, but I can tell you that that is the formula for that. Okay, so 2 times 30, 2 times 27, 27, okay, plus 2 times 23, plus 2 times 20, plus 2 times 18. Alright, now just plus 15 like that. So just keep in mind the first and the last do not have a 2 times. And actually what you're looking at is when you do the 2 sides here, like if you do this side and this side, you're only counting this here. But when you do this side and this side, you've already counted 30 once. So when you're evaluating the 2 sides, if you were to do, the 2 heights, alright, so right here on the ends, on this end, you're going to count 24 once and 30. So 24 and 30. When you count 30 and 27, that's 30 again. Alright, so 30 and 27, you've already counted 27 once. Okay, so when you count 27 and 23, that's 27 and 23 there. Alright, when you count 23 and 20, you count 23, you count 20 again. When you count 20 and 18, alright, you count 20 again and 18 once. And then when you count 20 and 15, you count 18 and you count 15 once. So that's why you have 2 times all these in between here. And on the ends, you only counted them once. Alright, so let's see what we get here. Half of 2 is 1, so really all we got is 1/12 on the outside. Alright, so 1/12 of all this. Okay, so let's see. 24 plus 60. Okay, plus 2 times 27 is 54. Okay, 2 times 23 is 46. You have to be very careful when you're doing this because, you know, you can use your calculator if you want. 2 times 20 is 40. That's easy enough. 2 times 18 is 36. And then plus 15. Okay, 1/12. Remember, that's because you're finding the average. So 1 over, we just already said that. 1 over 12 minus 0 is 1 over 12. Okay, like that. Alright, so I think I have the answer written over here. Let me look in my pad, see if I got it. Okay. Oh, alright. I think I did change a number, so that is going to change this answer here. Alright, so this won't do me any good. I changed the number, I think. Anyway, it's probably off by just 1. So well, actually by more than that. So here we go. Alright, so let's see if I can put it down somewhere. Well, let's see, let's add it up. I think we can get some stuff here. I've got a 60 and a 40. Alright, that is, we'll just try to squeeze everything in, 100. Alright, plus, okay, 24 and 46. 4 plus 6 is 10. And 2 plus 4 is 6, but that's 70 right there. Alright, so plus, I'm just going to stack it up. 70 here. Okay, so 100 plus 70. I'm going to circle as we go. Hey, here's another one, 54 and 36. That adds up to, what, 90? 4 and 6 is 10. 5 and 3 is 8, and 1's 90. Good, that's good. And then we have those two together, and now plus 15. Okay, so that is 5. And let's see, 1 and 9 is 10, plus 7 is 17. Alright, and 1 plus 1 is 2, and that is 275. Remember, that's times 1/12. So we had all of that. So times 1/12 is 275 over 12, of course. Over 12. Remember, you can put that over 1 right there. Now, that, I do believe, let me look this up on my calculator here. Alright, so 275. I think I had this on here somewhere. Well, let's do it. 275. 275 divided by 12. Enter. Alright, I got 22.916. Alright, so let's see. 0.9166666. 0.916, and you just keep doing that, and you hit this enter. That is 11/12. So that is going to be 22 and 11/12. So this answer right here, all this is 22 and 11/12. And that's what I said I would get from the last one when I said that we would average the left approximation with the right one. You add the two up and divide by 2. That is exactly what the trapezoidal is going to give you. Okay? Alright, so that is 22 and 11/12. Alright, almost 23. That's pretty close. Alright. So we can probably make this observation that the left approximation is an over approximate. It's an over estimate. This one is an underestimate. This one's getting pretty close. Alright, so that is the trapezoidal. And once again, I could have just taken this plus this and divided it by 2 and would have had the same exact answer. Isn't that great? Alright, but I did it a long way. Okay. Alright, let me erase all these check marks. I want to keep this here. In my next video, notice that delta x is 2 throughout. 2, 2, 2, 2, 2, and 2. In my next video, I'm going to do one where, and this may be 2, this between here and here is, say, 4, 3, or something, and then this between here and here is 3, and so on. They're not going to be uniform, but you can still do the problem, okay? So I'm going to show you that as well, but probably not in this video. Okay, maybe we don't have enough time. Alright, so 22 and 11/12, so I do not want to erase that. I want to keep all of these up there. Alright. Anytime you have a table, you're going to be asked to find an approximation. Okay, and they're going to ask you left, right, trapezoidal. I looked it up today. In the 2001, this was a 2001 question. I used different numbers. I said that from my last video. They wanted a right approximation. That's all you got to do is a right approximation. In the 2003, they had another one that wanted a left approximation. Okay, and you can look at my videos and you can see the difference between which one is left and right. Well, I got the video before this is what I did before. Alright, so the trapezoidal. Okay, we're just going to put trap for trapezoidal. Alright, approximation. And that was 22 and 11/12. Alright, good. Now, how do you do midpoint? Well, with midpoint you don't have as many subintervals, and what I mean by that, here we had this subinterval, and then, well, 1, and then I think we had 2, 3, 4, 5, 6. We had 7 subintervals on this each time. But what you do with midpoint is that you actually, your delta x is going to be more. It's going to be double, because if you look, here's your between. Alright, what you want to do is you want to start the left side. You want something between, say in this case, 0 and 4, which is what we're picking, 2. That's the midpoint between 0 and 4. Delta x is no longer 2. Delta x is equal to 4, not 2. 1/12 is still there. We are not multiplying by 2 anymore. We are multiplying by 4. Okay. Now, each time we get to a midpoint, we find the ELF at 2, or the ELF at whatever corresponds with that midpoint, and that is 30. So ELF at 2 will be 30. Now, do 4 more. So 4 to 8. 6 is in the middle. Look what ELF at 6 is. Remember, that's a summation, so that's going to be 23. Alright, and this is the reason I did this, so I could have this come out evenly like this. 8 to 12, that's 4. So I still got that 4 on the outside. And here is 10 in between those two, so 18 fits this. Alright, there it is. Forward 12. Alright, which is actually 1/3, right? And we're simply going to add these up. So 30 plus 23 is what? 53. So 53 plus 18, correct? 53 plus 18. So 8 and 3 is 11, and carry 1. 5 plus 1 is 6, and 1 70. So 71. So this is actually equal to 1/3 times 71. 3 won't go into 71. Y'all know how I know that? Because if I add the digits up, 7 plus 1 is 8, and 3 won't go into 8. If this been 72, perfect. But it's not. And I did, when I had on one problem before, I had this as 24, I remember now. And I had one more, this would have been a 72. Yeah, I don't remember that now. So 71 divided by 3. 3 2s are 6, and 1 7. We're going to bring down the 1. 3 times 3 is 9. 9 and 2/3. So 23 and 2/3. Alright, well, that happens to match for some reason the left approximation. That's not always going to happen, folks. It's not always going to happen. That is coincidental. Total coincidence. But it's okay. So again, 1/12 times 4, because we're taking delta x to be 4. And then now, that midpoint is 2, so F at 2. Midpoint between 4 and 8 is 6, so F at 6. Midpoint between 8 and 12 is 10, so F at 10. Add them up. Remember, delta x is 4, and you're going to multiply by 1/12. So 23 and 2/3. Again, had I changed this to 24, this would have been 20. I want to say 24 even. Yes. Let's see. 20. Let's see. Yeah, this would have been 24 on the dot. Okay. But anyway, I changed this number back because I didn't want these two to be the exact same numbers. So, okay. Alright, it doesn't matter. It's very rare. Do not say, just by looking at this, KP to the MFG, the left approximation is automatically the midpoint. That is not true. Okay? Not necessarily true. Total coincidence right here. Alright. We did a trapezoidal. Remember, on the trapezoidal, the first and the last are counted once. The first F at 0 and F at 12. But 2 times F at 2, 2 times F at 4, 2 times F at 6, 2 times F at 8, which is 20, 2 times F at 10, which is 18. And then 1 times F at 12, 1 times F at 0. Midpoint, boom, this is nice. That's why I added that extra one as opposed to what they did on the 2001 test. This is the easy way to do it. Alright, so that's, we did left approximation, right approximation, trapezoidal, and this one here was the midpoint. Midpoint approximation. Okay. Well, that's it for this time. The next video, please tune in for that one, because I'm going to change some numbers here just a little bit. Okay, we're not going to have a uniform delta x throughout all of this, and you need to see that one as well. And then the following video after that, we're going to learn how to find exact values. Of course, we can't do it from a table, but we can do it when we have some functions, some real functions that we have to deal with. Okay? All right. That's the lesson for tonight. This is KP, the Math G, signing off again. As a reminder, don't forget to hit that subscribe button and then make a comment. And one way or the other, I appreciate any comment that you make because I want to make you better. If you can say, hey, KP, could have done this a little differently, a little easier, I'm all for it. But it needs to be right. Okay, it needs to be right. All right, KP, the Math G, signing off. You guys and girls and ladies and gentlemen, have a great, great day.